Hi, welcome back to another Creative Tab tutorial. In this tutorial I'm going to be explaining the RGBA workflow within Nuke, or I'm going to be explaining the term RGBA and what it means. I've got a bunch of explainers here for us to look at, so it shouldn't take too long, but I'm going to make sure that by the end of this video you thoroughly understand what RGBA means. Okay. We won't be going into all the channels that Nuke works with, just like I said, RGBA. So let's dive on in. First of all, what I want to kind of make clear is I just want to very quickly go through exactly how images are made up inside of Nuke. So we've got just an image in here. Okay, so if we have a look at it, just a nice little image. Now zooming in, if we zoom in, you can see these little squares. Now you probably already know that images are made up of these little squares called pixels. Okay, so this is 1920, the resolution of this is 1920 by 1080, also known as Full HD. So that's 1920 pixels across, 1080 up. So if we just get my little calculator, let's just have a quick, let's just check how many pixels are in here. So if we type in 1920 times 1080 equals, so 2,730,600 pixels. Okay, they often say 2.1 megapixels, so 2.1 they rounded up, and megapixels because it's million. Okay, so it may be weird to you because you hear of phone cameras that have got like 15 megapixel cameras. Full HD is actually only 2 megapixels. Okay, so yeah, let's X out of that. Now let's get down to it. When you import an image or anything into Nuke, so we got our read node by here, let's bring it up. You can see that we've got three little coloured tabs by here. We've got a red one, a green one, and a blue one. And that's to show that this image that we imported has got a red channel, has got a green channel, and it's got a blue channel. Okay, because let's have a quick look at this. What that means is this image is made out of three colour channels, red, green and blue. All images on monitors use red, green and blue because they're what's called an additive, what's the word? Got it over here somewhere. Additive colour. Can't believe I forgot the word colour. So yeah, what we can do, if we zoom in, I'm just going to select a pixel by holding Control and click. And you can see this little red box means that we're now just selecting on this pixel. And as I do this, have a look at these numbers down here. The red set of numbers, the green and the blue. As I drag around, they're changing, okay? So what this is saying, if I just keep it around this one, what these numbers are saying down here, this pixel that I've selected, in the red channel, it has 0.99121 value. Now, these values down here, we're going to work today of saying they go from 0 to 1. Now that's not actually true. I don't want to confuse you, but this is Nuke is what's called floating point, which means it goes above 1 and below 0. But for today, let's just pretend it's between 0 and 1. Anything above 1 is 100% data in the red channel. Anything below 0 is like there's no data there. Okay, so this is very, very orangey by here, so it's no surprise that it's got a lot of data in the red channel, you know, a little bit, 0.2 in the green channel because it's got an amount of orange to it, and it's got 0.07 in the blue, so it's got very, very little in the blue channel. That makes quite a lot of sense, right? So if I go and select a pixel up here, so you can see I've selected this one by here, it's got 0.03 in the red channel, so that's saying there's not a lot of red in this particular pixel. It's got 0.1 in the green channel, so there's a little bit, 0.13, and it's got 0.17 in the blue. So most of the data is in the blue channel. Even 0.17, that's still quite low because it is still quite a dark pixel in comparison to how bright things are over here. So let's select a white. We've got 0.99 in the red, 0.83 in the green, 0.7 in the blue. So if you had pure white, it would be 111. Okay. Now, like I said, we're gonna measure these color values 0 to 1. If this was 0, there'd be absolutely no red data in there at all. If it was 1, it would be crammed to the limit full of red data. Like I said, with certain file types like EXRs, you do go above 1, but we will be covering that in a completely different video. So that's basically how images are made up of these pixels. Each different individual pixel has its own color value. When you put these 2 million pixels together of different colors, they give you your image, okay? And that's basically, in layman's term, how images are working inside of Nuke. So let's move on to Explainer 2, where we're going to look at it in a bit more detail. Now, I mentioned earlier that any colors on screen work in RGB because they're what's called an additive color model. When you're working in print, you may have seen this on the side of cereal boxes or newspaper. They have like little colors there. It works with CMYK, so that's cyan, magenta, yellow, and black. K stands for black. And when you add those 4 colors together, cyan, magenta, yellow, and black, they make black. And because they are, the way it works on paper is the ink stops when light wavelengths hit the paper, it blocks them, okay? But screens like the one you're looking at right now, they don't block light like the ink does. They emit light. So in order to create white light, RGB, you mix together red, green, and blue, and it makes all of those colors make white. And black would then just be the absence of any color data. So looking at this, if I source the pixels out here, now earlier I was just control clicking to do single pixels, but you can also click and drag to get an average, but they're all the same color, so it's fine. You can see this is black because there's absolutely no data in the red channel. It's zeroed out. There's no data in the green channel. It's completely zeroed out, and the same in the blue. So the reason that that is black is because it's completely absent of any color data. Let's come into the middle and just select this white area. So yeah, what we're actually seeing here is quite interesting. All completely full of data in the red channel, completely full of data in the green channel, completely full of data in the blue channel. They're all maxed out to 1. And, you know, that's understandable because we've got red crossing over, blue and green. So if we just select this area, you can see 0 in the red, 0 in the green, 1 in the blue. Red, obviously 1, 0, 0, and down here it's going to be 0, 1, 0, okay? Coming into here, we've got 1 in the green and 1 in the blue because these are crossing over. And I've merged them on top of each other and I've plussed them together. So that's why that's working like that. It's just adding them together. So you got your 1 in the blue from here, your 1 in the green, and they overlap. And the same will happen in these little intersections by here. Okay, so that's exactly what's happening there. Once these values are added together, they create different colors. And that's what's happening back in here. You know, this first image, for example, we selected a pixel. And it's got 0.07 there, 0.2 there. When you add data from these different color channels, a little bit of red, chuck in a little bit of green, a little bit of blue, you can get millions and millions of different colors, okay? So, example 3, I've got a constant here, and if you're not sure what a constant is, it's like in After Effects when you make a solid, okay? So, you can see it's completely blue. I drag over, we've got 1 in the blue, zeroed out in the others. And if I come over to the node controls of this constant, you can see that in here, this is why I've got your blue at 1, and then you can start, as I start increasing the green, if you'll notice, 0.32, 0.32 down by here. And as I add in green, it ends up making a sort of turquoisey colour. And if I add in a little bit of red, you'll now start seeing it goes brighter. So 0.57 up here, 0.57, let's decrease this to take some green out, so we're down to 0.01 in the green, and basically you can see as I introduce the colors they get introduced in here, okay? That's basically illustrating this with a constant, so just another way of illustrating it for you guys, okay? On to example 4. We're now going to look at the individual channels themselves, okay? So I've got this color bars by here. If we select the green, we've got 0 information in the red, 0.5 information in the green, and 0 information in the blue. Okay, now if you look up here where my mouse is, we can actually drop down and we can view the red channel independently and the green channel independently and the blue, and we'll come to the alpha later. Okay, so the shortcut key is RGB and A. So if I hold my mouse over here and I hit R on the keyboard, oh, what's weird, it's gone black and white. Okay, now just to explain, when you view, if we view this over here. It would be better to view this over here, right? So going back to our model earlier, if I hit R on the keyboard, it's showing me where the red data is. And we know that there's no red pixel data here because it says 0, 0, but we know there's 100% red data here. So if I hit R on the keyboard, what the software uses is a black and white representation of how much data is there. So there's absolutely no data out here, so it's completely black. But there is there's full data here, so it's white. So wherever it's white, when you go in the individual channels, you can see it says R up there, so we know we're viewing the red channel. Where it's completely white, there is full information within that channel. Where it's completely black, there's none. If it's grey, it's kind of anywhere in between then. So if I now hit G on the keyboard, we are completely white here, so because we're viewing the green channel. So completely white and black everywhere else. Same with the B. If we hit the B for the blue channels, you can see it's B up there. We know that it's showing us this because there's a blue circle over there. So black represents absolutely no data in the blue channel, okay, and white represents that there's full data, where black there isn't, okay. Now let's come back to our color bars. Okay, so we know there's red. Let's have a look. We know there's no red here, so when we view the red channel, zero doubts that should be black. There's 50%, 0.5 here, okay, so that should be semi-grey. There's also 50% within this purple by here, so that should be 50% grey. None here, none here. There's 50% red in the yellow, and there's 50% red in the white. And there may be some stuff down here. So let's hit R on the keyboard. And as you can see, these two aren't white, they're grey. And we knew there was 50% red over here. Okay, let's come back. Let's do the same with the green channel. No green here, so keep an eye on the numbers down here. No green in there, no green in there. There's green here, 0.5. 0.5 green here, 0.5 in the yellow, and over here. So these should all be like semi-grey. So if we hit G for the green channel, see it says G up there, that's a representation. There's no green data by here, as you can see when I drag this around, but there is 0.5 of it over here and probably more down here apparently. So it would be the same with the blue then. So there's 0.5 blue there, 0 represented by the black, 0.5 because we're grey. Now if we just come out, what I've got down here is a grade node. So what will happen is when if I start gaining up these colours, which means making them brighter, have a look, because I've selected let's put that back to 1. I've selected pixels in the purple, 0.5 in the red, 0.5 in the blue. Watch as I gain them up now. Okay, they are going up to like 0.9 there. So if I go back to the red channel, you'll see that that is now a lot brighter than it was earlier. If I disable this node, you can see now it's really grey because it's saying 0.5. If you turn this grey node back on, it goes to 0.9 and that got brighter. Again, if I gain it down, so you can see as it reaches 0.01, it's nearly going completely black. But as I gain it up all the way to 1, it gets white. Okay, so what it's saying is viewing the red channel, there's 0.2 in there. But as it gets to 0, it's black because that's the black and white representation. So hopefully you kind of all understand that. Very quickly to illustrate that, we'll do this now with an image. So if I hit R for the red channel, understandably, this area here is whiter because there's a lot more red. You know, it's very orangey. There's a lot more red in here, okay? And there's not a lot of red in these areas at all. Okay, so that's what's happening there. If we hit G for the green channel, that'll be a real mixture. If we hit B for the blue channel, you see that red area is darker, it's brighter up here, and it is a little bit brighter by here because there is a lot of blues within there. So the blue and the red channel illustrate it. A lot of red data there, not a lot in here at all, and up in the corners. If we go to the B for the blue channel, it's almost like the reverse. There's not a lot down here, and there's more kind of in the foreground in the sky then. Okay, so that's how color channels work. Okay, example 5 now. We are back with our lovely little diagram, okay? So let's have a quick look. Remember earlier in the video, I mentioned we've got our constant, which is our first, let's view that, which is our first input by here. And it's only got the red, the green, and the blue tab. and there's no data in the red, there's no data in the green, but there's data in the blue. So we understand that. However, when we come down to the RotoPaint node, if I view that, or if I view here, because the other channel we're going to look at now is alpha, which is the shortcut is A, and it's represented by these white numbers. If I hit A on the keyboard, absolutely black, because again it's zeroed out, there's no alpha information. However, if I come down to the RotoPaint node, view that, we've got a white circle. Now I'm viewing the alpha channel, so that's saying as I drag, see as I drag this by here, 0 in the alpha, but as I drag it by here, 1, so we've got data, because what I did is in the, so I'm out of the alpha now, I'm not viewing the alpha channel. What I did is in the RotoPaint, I drew a circle and I outputted it to alpha, so I created a circle full of alpha information. Because what alpha information is used for, if you've come from After Effects again, you may kind of be aware of this using track mats and stuff, or when you're keying. It's basically used, if we use a pre-melt node, and I've got a video going through the pre-melt node, it basically uses the alpha information and uses it as a cookie cutter. So that's how I made the circles for each of them. So the constant, no alpha data. If I hit the alpha channel, nothing there. Let's get rid of them. I then created, you can see there's that white tab all of a sudden, because this RotoPaint, I created a circle of alpha. When we use the pre-melt node, it cuts it out. It doesn't up here, but it does here. Again, like I said, I got a video going through the pre-melt node, and then I plus them together. So same thing is happening, only red, green and blue tabs by here. I created an alpha, so you can now see that white bit represents alpha. Okay, so that's how I made that one. And you can often make alphas with roto nodes. However, that might not be the case. I'm going to have a look at 2 more examples. Let's delete that. Got my lovely image again. You can see it comes in with just red, green and blue data. Now what you can do, if you want an alpha channel, because if we look at the red, let's delete all of these actually. If we look at the red, we got that red data, green data, blue data, like we looked at earlier. If we hit A, there's no alpha channel there. That may cause problems when you're compositing. You may need an alpha channel depending on the operation of the merge that you're going for. Again, more of that in the future. But what you can do, double click the read node, click auto alpha, and it gives it, so if I come in and out of A, it gives it an alpha channel, okay? Completely fills it with alpha. And then you can now see we got this tab here. So if I click off it, it disappears. If I click on, it's giving you an alpha, just completely fills it, floods it with alpha. Now, you know what? If you are working as a compositor, that's actually not the best workflow. If you need to create an alpha, that's not the best workflow, because other compositors who you pass your shots on will have to double click, may have to double click into the node to see exactly where that alpha is coming from, and they may be like, oh, it's not really clear. So a really good and professional way to do it is to create a constant, and again that's just like a solid inside of After Effects, and you can double click on this constant. Channels that it's creating at the moment, it's only creating red, green and blue channels. What you can do is just change this to say only create an alpha channel. Okay, so it's creating an alpha, and you change this all the way to 1. So if I view this, go to the hit A, so we're viewing the alpha. Because I dragged this all the way to 1, it's now completely flooded it. So it's done the same thing, but you want to copy this into your stream. Okay, so again we've got red, green and blue here, and we've got just a flooded alpha channel that we've created. If we get the copy node, so that's K on the keyboard, connect your A and B like that. Actually, I'll probably switch them around. What you've got, if we view this, what it's doing is it's taking your alpha channel from the A pipe and copying it down into your B. So basically, it's a better way, instead of going in here and clicking auto alpha, okay, what you're doing is you're saying to your whoever you're working with, like RGB's coming in here, instead of going in there and enabling it, it would come up with a little thing by here, so it's, you know, it's not too bad, but you're saying, look, I'm copying in an alpha channel to the node stream now, and that's just a cleaner way of doing it, and nicer when people do that, because it's just clearer what's going on. Okay, our final example then. We've got a little render by here of a CG football in a park, okay? And again, this, if we view this, it's got red, green, blue, and alpha data. I haven't clicked auto alpha, so if we view the alpha data, it's only where the football is. And I'm just illustrating why this would be useful. Okay, so if we go red, green, blue, we can see there's not a lot of blue in the grass because it's really black. So there's not a lot of blue data in the grass. Surprisingly enough, there's a lot of green data in there. There's a lot of green in the sky because the sky is quite white, so it's got a lot of colour in there. And if we hit R as well, there's actually a fair amount of red in the grass. Okay, because you can see actually there actually is a lot of red in the grass. Okay, so we've also got our alpha in here as well, and it's just basically cookie cutting out the football. So if we now, that's handy because if we want to take the football out or grade it individually, I'll show you that example now. We can pre-melt it and it cuts it out. But again, if you want to just grade that football, because this has come from software package or something, and you want to just grade that football, what you can do is in your grade node, this is why alphas are useful, you can say mask by my alpha, and now whenever I make any alterations, it's just going to do it to this bit. If you hadn't have masked, it does it to the full image, okay? But if you say mask by the alpha channel, so tick that, then it's just going to alter this. Okay, so that's another reason why alpha channels, if they're imported and you don't have to create them, that's why they can be really, really useful. Okay, you're just modifying that football. So if it wasn't color corrected, you could color correct just this football based on your alpha by using it as a mask. Otherwise, if you don't, like I said, just does it to everything. Okie dokie. Right. I hope we found that useful. I hope it kind of cleared up what RGBA is, why you need to know that as well. Like I said, check out some of the other Nuke videos. Leave a comment of what you want to see next, and cheers for tuning in. Thank you.